Ladies and gentlemen, boys and girls, children of all ages, today we begin division. As I will be doing for the rest of this week, I will be recording these lessons and I will put them on the Classroom of Google. So if for any reason you're absent, you can check the Classroom of Google after this class time is over, and you will be able to see how I taught these lessons. And anytime you're absent, check the Classroom of Google and check it a couple times a day because I add the videos and stuff to it. All right, we're going to start division. We're going to start with a single-digit divisor. As you already know, this is the divisor. This is the dividend. And this is the quotient. So that's your vocabulary. That's the divisor, the dividend, and the quotient. The divisor, the dividend, and the quotient. Now, when I'm working out these wonderful math problems, I prefer to, let me move that a little closer here. I prefer to write it the standard way that you've always learned, which is 375 divided by 9. If I say, hey, what's the problem? And you say 9 divided by 375, this would be the opposite way around, and that problem's going to be very difficult. I mean, it can be done, it's just going to create a little bit more work for you. Now, I know you can do this fairly easy. You know your multiples of 9. And if you don't, you have a multiplication chart. But in order to show you the process, I'm going to go through this problem and the next two problems as if they are problems that have a two-digit divisor. Because that's our goal, is to understand with two-digit divisors. And you don't know your multiples of a two-digit divisor. So when I'm doing a division problem, I'm going to list the multiples first. So I'm going to go times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. 9 times 5 is 45. 9 times 6 is 54. 9 times 7 is 63. 9 times 8 is 72. And 9 times 9 is 81. Now I'm doing that no matter how many digits are in my divisor, I'm going to do it that way. Because now I'm done with my multiplying. All I have to know now is subtraction to solve the problem. Now I'll do multiplication to check my work. But all I have to do now is subtraction to solve the problem. So how do I use this? How do I use this knowledge? First, I'm going to check, and I'm going to find out what 9 goes into. And this is really important to do it this way, so I put my numbers in my quotient in the correct place. Is 9 going to go into 3? No. No. I am not going to put anything above the 3. Ain't going to happen. Does 9 go into 37? Yes. Yes. That means my quotient is going to have a two-digit whole number. My quotient is going to have a two-digit whole number. A number above the 7 and a number above the 5. It is very important that that's where you put them. And you'll see that is more evident when we get on one of the later problems. Now, I know 9 goes into 37. Once I look at my multiples, I need to be as close to 37 as I can get without being more than 37. So I have 9, 18, 27, 36, 45. 36 is as close to 27 as I can get without going over. 36 is as close to 37 as I can get without going over. So that means 9 times 4 is 36. That means that 4 goes directly above the 7. I've already done my multiplication, so I know 4 times 9 is 36. Now all I have to do is subtract. And 7 minus 6 is 1. After I subtract, I bring down my next number. And that is 5. I am only putting one digit at a time on the top. If you start placing more than one digit at a time on the top, you're crazy. One digit at a time on the top. Don't be crazy. That's my job. But I'm crazy for other reasons, not for putting more than one digit at a time on the top. Now, again, I go back. And I need to take 9 into 15. That's why it's important this number goes over the 5. I go back to my multiples, and I want to get as close to 15 as I can get without going over. So what's as close to 15 as I can get without going over? 9 times 1. 9 is as close as I can get. And then I do simple subtraction. I have 15, subtract 9, and it is what? 6. So I have 41, remainder 6.
Yes.
Now I'm not gonna check these with multiplication today, but I'm going to show you how it's done. To check it, to make sure my answer is right, I would multiply 41 times 9, and then I would add 6. And if I did everything right, I would get 375. That's how I would check it. I'm not going to do that right now for this example, but that's how I would check it. That's how a would check would a would check if a would check could check would. I don't know.
So you do 41 times 9 and then plus 6?
And then add the remainder, yes. You do your quotient times your divisor, and then add your remainder in. And then if it equals 375, then we probably have the right answer unless we made a mistake on both parts. The second one was 841 divided by 7. 841 divided by 7. So the first thing I'm going to do is I'm going to list my multiples of 7. Now right now with one digit divisors, you have those multiples of 7 in your multiplication chart. So I do times 1 is 7, times 2 is 14, times 3 is 21, times 4 is 28, times 5 is 35, times 6 is 42, times 7 is 49, times 8 is 56, and times 9 is 63. I don't have to go any further than 9 because I'm only putting one digit at a time up on the top. So I don't have to go 7 times 10 and 7 times 11 because I'm only putting one digit at a time up here. So I only need to know my one digit multiples. Alright, so then I ask myself, does 7 go into 8? Yes. That means my quotient is going to have a number above the 8, a number above the 4, and a number above the 1. I'm going to have a 3-digit whole number as my quotient. 3 digits in my quotient for a whole number. Now I go over here. We said 7 goes into 8. So I want to get as close to 8 as I can without going over. So which one is it? 7. And so that's times 1. 1 times 7 is 7. Then I subtract. 8 subtract 7 is 1. Bring down my 4. Now I look here, and I'm trying to get as close to 14 as I can without going over. And what is as close as I can without going over? 14. 7 times 2 is exactly 14. I get 0, and I bring down the 1. This is why it's important to know how many digits are in my quotient. Because I promise you what I'm going to see is I'm going to see people not put a number up here. Just leave it as 12. And that's not correct. I have to have a number above this 1. How many times does 7 go into 1? 0 times. Now I have a remainder of 1. That is why at the beginning, when I first start to solve the problem, is I figure out how many digits my quotient needs to have. Because I promise you, those that don't do that, if I give this exact same problem again, those people that don't do that on a test or an assignment are going to put 12 remainder 1. And they're not going to see if their answer makes any sense, because they should know that 12 times 7 is 84. It's not 841. Let's look at another problem. 316 divided by 3. 316 divided by 3. Does 3 go into 3?
Yes.
Yes. I'm going to have a 3-digit whole number as my quotient. Now, I'll probably have a remainder. How do I know we're going to have a remainder? Because I know my divisibility rule for 3 is the sum of the digits is a multiple of 3. 3 plus 1 is 4. 4 plus 6 is 10. So I know I'm going to have a remainder. Because 3 doesn't go into 10 evenly. I'm going to list my multiples. 3, 6, 9, 12, 15, 18, 21, 24, 27. And again, I only have to go to 9. I only have to go to 9. Now we said 3 goes into 3. We said 3 goes into 3. I come over here and look. I want to get as close to 3 as I can get without going over. And what's as close as I can get without going over? 3 times 1, because 3 times 1 is 3. And I subtract, and I bring down the 1. This is another example why it's very, very, very important to figure out how many numbers are going to be in your quotient. Because what I see a lot in my 77 years of teaching is people go, oh, I'll just bring down the 6, and then I'll put 5 up here and put my answer is 35. And that's not correct. Because I have to have a number above the 1. How many times does 3 go into 1? 0 times. 0 times 3 is 0. Subtract, I still get 1. Now I bring down my 6. How many times does 3 go into 16? Yes, Maddox? Give me just 10 seconds. Yes. Logan and Mia, leave your computers, take your stuff, and go to the nurse's office. Take all your stuff. You don't have to leave your computer, Mia. All right, so what did you do, Maddox?
When I said 3 goes into 3 times, I said 3 goes into 3 one time because 3 times.
Oh, you're right. 3 goes into 3 one time. Thank you, Maddox. Why did I get all of this problem that far without somebody correcting me? Now I need to take 3 into 16. What's as close to 16 as I can get without going over? 15. So that's 5. which is 15.
I have the big one.
Subtract. I get 1. So I have 105, remainder 1. 105, remainder 1. Now right there, most of you are like, one-digit divisors, these are easy. Why do I have to list all my multiples out? Because we're going to learn later this week that when you don't list the multiples out, you're causing more work for yourself and more stress for yourself. I promise you. Boom! Shakalaka, peace out. God bless. Love you. Do something kind today. Save the bees. Subscribe to Keller GBB, please.